What is a polynomial? A polynomial is a mathematical expression made up of variables, coefficients, and exponents. Let's look at this polynomial. Now, remember the word poly means many, right? Or many nomials, if you will. This would be called a trinomial simply because it has three expressions, or three terms. Trinomial, tri meaning three. And within this polynomial, within this trinomial, you have a leading coefficient. Remember, a coefficient is a number and a variable, right? And so you have a leading coefficient of 1. Now, just because you don't see it doesn't mean it's not there. You don't need to put a 1 there because 1 times x is simply x. So a number times a variable is a coefficient, right? And then this has up to 2 degrees, simply because you have the exponent 2, and this right here would be an exponent of 1. These are the 2 degrees of the polynomial, right? Now remember, just because you don't see the 1 there doesn't mean it's not there. It just doesn't need to be there. That's why they don't write it there. And then there's a constant of 20. A constant is a whole number by itself, not being multiplied into a variable, no exponent, nothing, just a number by itself. That's a constant. Now, how would we solve something like this? You're wondering how. Well, it's already solved, right? It equals 0. But we need to factor it. We're going to be using the factoring method. We're going to use the factoring method, and we're going to factor out this expression, this polynomial expression. So first, I want to use what I like to call the cross method. And it's just something I named it. Has nothing to do with nothing. Other people have different methods of solving polynomials. This particular type of this works for me for this particular type of polynomial. So this is what I'm going to use. So now let's look at the very first expression. Let's look at the very first expression. You have x squared, all right? X squared basically means x times x. And remember, we're big kids now. We don't use the multiply sign. We don't want to get it confused, so we just use a dot, right? So x squared means x times x. So we already know off top there's no leading coefficient in it, so we don't have to worry about that. That's going to be a different situation. But for right now, we're keeping it simple. It's just x squared. So that means x times x. So we're going to put x over here and an x over here. And that means x times x. That's what represents the x square, right? And then we need to figure out the now we have the coefficient negative 9x and then the constant 20. We need to think of two numbers that multiply to make 20, but also combine or add to make 9. Or to make two numbers that multiply to make 20 or combine to make negative 9. How would we figure that out? So let's think. What are the factors of 20? Well, one of the factors of 20 would be 5 and 4, right? We know that 5 times 4 makes 20. Positive 5 times positive 4 make positive 20. So we got that out the way. We're good on that, right? However, let's think about this. We still have a negative 9 over here. We still have a negative 9. So positive 5 times positive 4 do make positive 20, but positive 5 plus positive 4 don't make negative. On the right track, we just need to do a little tweaking, right? We just need to tweak some things out a little bit. So what shall we tweak? Let's tweak, shall we? All right. So let's try and make, instead of using a positive 5 and a positive 4, let's make this a negative 5. Negative 5 times positive 4, or negative 5 plus positive 4 make negative 1. So that won't work, right? Well, what if we place a negative over the 4? And positive 5 minus 4 make positive 1. So that won't work either. Well, how about we make both of them negative? So now let's check the 20. Negative 5 times negative 4 makes positive 20. Remember, a negative times a negative makes a positive, right? So we're good on that, right? Okay, great. And negative 5 plus negative 4 makes negative 9. So we're good on that, right? So now you're wondering, well, we factored negative 9 and we also factored positive 20, but it's not just negative 9, we have a negative 9x. How does all of this gooble gobble add up to create this whole expression right here? How does that even work, right? Well, this is why we set it up this way, to make it easier for ourselves, to make it easier on our eyes. So in this particular case, let's say you have x times -5. And then you also have x times -4. I'm taking my time with this because most people aren't familiar with this method. And so a lot of you are being introduced to this concept for the first time. So I'm just gonna really take my time, right? And so let's place it over here. Let's put it over here. We already know that x times x gives us x squared, right? We got that. And then x times -5 will give us -5x. And x times -4 will give us -4x, right? And then -5 times -4 will give us +20, right? So now the only thing left for us to do is to combine these two terms, combine the like terms. If you remember from middle school, combine the like terms, right? -5x minus -4x will give us -9x. And what does this look like? This looks like what we just started with. So basically, we factored it out correctly. This was just a test. We factored it out correctly. But now let's make sure, let's solve for x. We factored it. We use the factoring method, but we need to use that factoring method in order to solve for x. So we know that x, let's put a separator here. And we know that -5 we can say x minus 5 equals 0, right? Because that's a -5. And x minus 4 equals 0. So we know we factored it correctly. So now let's use our middle school math and solve for x. And so if you remember, this is a -5, so we eliminate it by using +5. Whatever you do to one side, you do to the other, right? So therefore, x will equal +5. And at this point, you should have enough common sense to know that we use our middle school math, and this will give you x equals +4. So now you're wondering, why does it have two angles? Or two answers, I should say. Why does it have two answers? Why does it give me two x's instead of just one? Well, the reason being is because when you graph the equation. So if you were to graph this equation, x squared minus 9x plus 20, you would notice that it crosses the x-axis twice. It crosses it once at x of +4, and then it crosses it again at x of +5. And so this is why when using the factor method or any kind of method to solve a polynomial, you'll get, or I should say a trinomial with 2 degrees, you'll get two answers. This is a much more simplified scenario. Here, instead of -9x, you have a +9x. And you would apply the same concept, right? So we know that 5 times 4 makes 20, right? +5 and +4. And 5 plus 4 also make 9. So both of these would be positive. And so in solving it, you would basically take the x, you would take the x's, in fact, you would factor the x's. So in this case, you would have x plus 5 equals 0 and x plus 4 equals 0. And you would use your middle school algebra, solve it backwards, and you would end up with x minus 5, x equals -5, and x equals -4. So once again, if you were to graph this, you would see that it crosses the x-axis twice, once at -5 and once at -4. So my favorite quote is, if you get the math, you get the graph, right? If you get the math, you get the graph. So just based on these answers alone, if you look at this equation and you factor it to solve for x, and you get the answers x of -5 and x of -4, right? And you can see that this coefficient is positive. You have a positive x squared, so you know that the graph is going to open upwards. And then you can already see that the crosses the x-axis at -5 and -4, so you know it's going to be on this side of the grid. And so in your mind, you can already have an idea. You can already start putting together what the graph is going to look like just by looking at the equation in and of itself. So if you get the math, you get the graph.